Hey Geometry, we are now getting into the most fun things in my eyes are these prisms and cylinders and talking about them. So first let's get a definition of a prism down. It is a polyhedron, which we talked about yesterday, with two congruent parallel faces. So let me show you something. I went to St. Peter's and got some. So we got, this is a prism. And this is a prism. And we got some bigger prisms. There's a prism. There's a prism. And here's a prism. And I think that's all I have. So, what makes something a prism? I'll show you those more in a minute. It has bases. And the bases are the two congruent parallel faces. So when you look at this prism, the bases are right here and here. These are the two bases, the part that I'm holding here. Okay, so on this one, you can see the sides here are rectangles, but these are triangles, and these two triangles are the bases. And then these squares are the faces. Okay. That's also a prism. And the top and bottom are the squares. Those are the bases. And then the ones around are the faces. And here's a little guy. Just a little one. Little triangular prism. Okay. Notice the sides though. The sides here are rectangles. Okay, so the lateral faces are all the other ones that aren't the bases. Okay. It's all the bases between the bases, basically. Sounds like a, I don't know what, tongue twister. And the altitude or height of it is the perpendicular, remember 90-degree segment, joining both the bases. Now here's the deal. These ones that I showed you right here, all these, those are all right. They're all straight up and down. They don't angle at all. But you could have an oblique one, and that would happen if, just take this top off here. Let's just pretend this top was over here. Okay, I gotta figure a better way to do this video. Okay, I'm blocking my light. Let's try this. If this top was over here, and then the base was on the bottom here, and it was kind of like this angled. This is harder to do than I thought with this camera. If it slants to one side or another, it's called oblique. Okay, so right is basically going up and down straight, and oblique has a slant to it. The bases are still parallel though. They just are, the middle part angles. Okay, so we have two different terms now to talk about. We have lateral area and surface area. So when you look at this one, we talked about how these hexagons, these two hexagons, those are the bases. So when they say, what's the lateral area? It's all this stuff around it, okay? It's all the stuff around it. It's not the bases. So it's the sum of the areas of all lateral faces. And if they say, what's the surface area of this? Well, that's everything. That's like, I'm going to wrap it in wrapping paper. And how much wrapping paper would it take to cover the entire thing perfectly? So that's your lateral area. And if you notice up here, lateral area is always abbreviated LA, and surface area is always abbreviated SA. So it's your lateral area plus what? The two bases. right? That's the only part we didn't include in that. Plus the 2 bases, and lo and behold, you're going to find out that's the formula in a minute. All right, but before we get to the formula, let's take a look and see, can we figure out the surface area of a triangular prism using a net? So you guys practiced these nets before. This is the figure you see before you. It's a triangular prism because it has triangles for the bases. So it's called triangular prism. Okay, so if we were going to unfold this, we would have a rectangle, right? And then these other 2 sides here would open up. So those would be here and here. And now let's get those dimensions on there. Excuse me, it's 12 inches and 6 inches. So these are all 6. And this is 12 and 12. So the only part we're missing now are these triangles. And remember, we can just take them off of one of the sides, not all of them. Because when you bend that up, those sides will touch this side, will touch this side. Actually, I'm lying. They aren't all 6, are they? That is incorrect, because the triangle, these are 5s. Okay, I'm doing that wrong. I'm glad I caught that. These sides are actually 5, because the triangle is 5. Well, that explains it, because before I wasn't getting the right answer, and I'm like, why am I not getting the answer? The book must be wrong. But now I have figured that out, so that's good. So let's take a look now. So we need to get the area of these 3 rectangles. Okay, so we're going to just basically add them all together. We know area of a rectangle is length times width. So the area of this rectangle is 12 times 5, 60. The area of this rectangle happens to be the 6. Remember up here, one of them was 6. 6 times 12, 72. And then we got the one over here, 12 times 5 again, which is 60. So far we have 60 plus 72 plus 60. Now we just need the 2 triangles, and they're both the same, so once we get one, we can just double it. So we have a triangle, 5, 5, and 6, and we need the area. So we've got the base, which is 6, but we need the height. And you know mathematically how to do this. You know that this side is going to be a 3, and if I need the height, we'll use what? That's right, Pythagorean theorem. So 3 squared plus height squared equals 5 squared. 9 plus height squared equals 25. Subtract the 9 from both sides, and we get h is 4. So I'll go down there and drop my 4 in for my h. 24, half of 24 is 12. Okay, so that's one triangle. This was 12, and this one was 12. So plus 12 plus 12. And when you add those all together, guess what you get? I don't know. 120, 24, and 72. I just added a few of them. 6 to 16. Oh, lo and behold, we get the right answer when you do it the right way. Okay? But that's complicated every time to have to figure all that information out. So they put that all into a formula. And those are right here. Oops, let me get this lined up. Right there. So those are 2 formulas you're going to need to memorize. So you could put them on note cards or something to practice, maybe, because you're going to have a lot of formulas on this chapter. So maybe you want to have the prism ones on one note card and cylinder on another or something like that. But I wanted to show you something with this. When you take, I had this piece of paper here just to show you visually this. I looked up this. This is the lateral area, that paper, right? The outside, everything but the bases. So when you look at the lateral area formula, it's the perimeter times the height. Well, what's kind of cool is if I take this out, you'll see something. It's a rectangle. Base times height, or length times width. And what's the length here? The length is all of those sides added together of the hexagon. It's the perimeter. So that's how they came up with that. And then, of course, once you get this figured out by doing the perimeter times the height and getting a lateral area, the only thing missing are the two bases. And that's why when you see surface area, it's the lateral area plus the two bases. Okay, and now notice a couple things here. Capital B is for area of the base. And little p is for perimeter of the base. And of course, h is your height of the prism. Okay, so that's another thing that some people get mixed up. If they take a triangular prism like this, and they're looking for h, some people will go and take the h of this triangle on the set it down there. The height of this triangle. No, that's the height of the prism from top to bottom. That's this length over here, the height of the whole prism. Okay? All right, so let's practice this now. What is the lateral area of the prism? Okay, so let's grab our formula. First thing you do is write your formula. And you can see what you need. I need perimeter and I need height. I'll lower this again. You can see a little clearer. Okay, clear. Okay. So I'm going to go over here and I'm going to get my perimeter. Perimeter, just I see all these dash marks. That tells me they're all the same. And it's 6. And I need the perimeter of the base. And this is my base. So 6 times 6. There's 6 sides. My perimeter is 36. So I've got one of the two things that I need. Now I need the height. And I put parentheses just to make sure I don't forget. I'm missing something. I'm not done with my problem until I get that. The height is, again, between the two bases. It's the distance. So it's right here. This is your height. And although this, you may say this looks oblique, it's actually a right prism. And a lot of times they'll tell you, and I would say I pretty much assume it's right unless it's obvious that it's an oblique. So I'm going to put that in there. You grab your calculator, go ahead and multiply that out. And it is 432 meters squared. All right. Next, what's the area of the base? Okay. So the base here, here's my base. We need the area of that. And it's simplest radical form. That means, remember, radical is square root. So that means you're not using your calculator to multiply out the square root. You're leaving the square root in there. And you've done these now in the last problem. Remember where we drew our triangle in here? And I'm just going to rewrite it right here. If the whole side was 6, this little part is 3. And we just need this degree measure right here. And it's a hexagon, so we would know this whole thing would be divided 6 ways. 360 divided by 6 gives us 60. And then I'm only using half of it, so that means this is 30. And how slick is that? It's a 30, 60, 90. And they give us the one across from the 30, which is the x. So that's really nice. And we need this, the apothem. Because let's back it up for 1 second. To get the area of a polygon, remember it is 1/2 AP. So I should have written that first, but we are doing the apothem right now. We need this right here. Okay? And so if this short side is 3, then remember the longer side is x root 3, or in this case, the x is 3, so 3 root 3. And now I just need my perimeter, which we already knew was 36. We did that earlier. So I can do these, they're all multiplied, so I can do them in any order. So I'm going to do half of 36 because I know that's 18. And then 18 times the 3. I can multiply all these whole numbers. I just can't go inside here. So half of 36 is 18. And then 18 times 3 is 54. And so my answer is 54 root 3 meters squared. That is in simplest radical form. All right. Now, what is the surface area of the prism rounded to a whole number? Okay, start with our formula. Surface area, LA plus B. So notice the pattern here. First we got the lateral area. Then in order, they're looking ahead, okay, down here, because they know to get the surface area, we needed the lateral area, and we needed the area of the base. So they're walking us through this. In a problem, it might just say, what's the surface area? And then you need to do that information first. But now it's pretty well laid out. We just need to plug it in. LA was 432, and the area of the base was right here, 54 root 3. So it says round to the nearest whole number. Okay, so first I'm going to reduce it as much as I can. 2 times 54 is 108. So I would do this part first and multiply it. 108 times root 3 equals 108 times 3 root equals plus 432 is 619.06, and it says whole number. So the whole number is the 9, where the 9 is. So it'd be 619. And meters squared, it's all area. All right, kind of a little bit of a long section. We have to talk about cylinders now. So I'm going to put my prisms away. And lo and behold, I have a cylinder. So now a cylinder, of course, is similar to a prism. It is a solid with 2 congruent parallel circles. So my 2 circles, there's one, and flip it over, there's the other. Okay. The bases are the 2 circles. And there aren't any other faces in here because it's round. The side is round, so there aren't any other polygons. The altitude or height is the same thing. It's the perpendicular segment joining the circles. And right and oblique is the same as always. This is a right cylinder. It's going straight up and down. It's not angled over. Okay. So let's take a look at our very last page here. So we have now the formulas. And again, I might make a note card with cylinders and put these 2 on it until you learn them well. The lateral area is, this is all multiplied. So you can multiply in any order. 2 times 5 times radius times height of the cylinder. Again, that would be the side over here. Okay. Now, surface area, it is the same as a prism. But notice, considering we're working with a circle, if you remember lateral area, let me just show you that real quick on the other sheet. At the top here, lateral area was perimeter times height. What was perimeter on a circle? That's right, it's a circumference, which is 2 pi r times the height. That's where they get that formula. Okay? And the same thing kind of happens over here. Not kind of, it does. Lateral area plus 2 times the area of the base. Well, lateral area is right here, 2 pi rh, plus 2 times the area of the base. Well, it's a circle. Area of a circle, pi r squared. 2 of them, 2 circles. Okay? So in order to figure out lateral area and surface area, all you need is your radius and your height. Cylinders are easier to work with than prisms, for sure. So let's look at this. Cylinder has a height of 9. And what I do is when I'm reading problems, I just go right by it and circle it. So I'm like, okay, h is 9 and a radius of 10. And if they had said diameter, I would have split it in 2 and put, what the radius was then. What is the surface area of the cylinder in terms of pi? That means we're not multiplying the pi out. We should have pi in our answer. Okay? So it's surface area. Make sure we get the right thing. So surface area is equal to 2 pi RH plus 2 pi r squared. And I want to see this on your homework. Really well done. I want to see the formula and just drop it in. It's really kind of fun once you get rolling. So 2, the pi, those don't change. Radius was 10, parenthesis, height 9, plus 2 pi, radius is 10, squared. Now how many terms do we have? We got 2 terms here. Okay, so you got to work though each of those terms themselves. So I'm going to multiply in any order this part. I can't bring it over here. So 9 times 10 is 90, times 2 is 180 pi, plus, got to do the square first, 100 times 2, 200 pi. And this is kind of like working with x's or variables. If you got 180 pi and you're adding 200 pi, since they're both multiplied by the same number pi, you can combine those together and you will get 380 pi, that's the unit, centimeters, don't forget your units, squared. So that's what they're talking about when they say in terms of pi. Okay? All right, last one. I need you to flip your books to page 703 and take a look at that stencil roller so you understand what I'm talking about. It's a little stencil roller. It has a height of 1.5. It has a diameter of 2.5. So like I said, I'm going to do the math in my head. Half of 2.5 is 1.25. So I'm just going to put that right there so I have my information that I need. What area does the smaller roller cover in one turn? So if we have a roller, and we're talking about how much it's going to cover in one turn, we're not talking, these sides, the circles never touch, do they? It's the, what do we call that? It's the lateral area. Okay, when we add the bases to it, that's the surface area. But the bases aren't covering it. So we only are looking for the lateral area in this one, which was 2 pi RH. So I think we got it all. 2 pi, radius is 1.25, height is 1.5, nearest tenth on this one. So we're going to go ahead and multiply 1.25 times 1.5 times 2 times pi, and I get that. Round to the nearest tenth. So the tenths place is where the 7 is, so I look after it and I see an 8, so I know I need to round that up, 11.8. And inches squared. I just have to think for a second. Am I doing area? Am I doing what? So there we go, guys. I know that was a little longer, and the next one is a little bit too, but if you could, please get my recommendation, or do my recommendation of the note cards. To hear you, if you write me an email and tell me you're doing the note cards, like, I'll be super happy. Okay? All right. Thanks, guys. Have a good day. Bye.